Hi everyone. Let's have a discussion on the third module. Third module we have to start today. That is pilot relaying schemes. Okay. So what is the meaning of this pilot relaying? Okay. See, there is a pilot wire. That is a communication cable between the two relays. Okay, located at the different ends. Whenever a transmission line or equipment is to be protected by using a differential relay. A wire is connected between the CTs. Okay, one end here CT and another end one more CT is there. A wire is connected between the CTs which are located in different ends of the protection zone to provide the path for the circulating current produced in an abnormal condition, that is fault condition, which is sensed by the relay, and therefore the relay breaks the circuit. Is it clear? Pilot relay means what? It is an extra connection. Okay, this is a relaying scheme used to protect transmission line sections. Okay, see here in the figure. See here, this is what pilot relay we have connected one transmission line at the starting and one more transformer, second transformer at the end. Here we are using, with the transmission line we are using extra two lines. Okay, two wires, that is the pilot relay to protect the system in the abnormal condition. Extra two wires used with the transmission line, like telephone wires, microwave lines, carrier current, extra carrying lines we have to connect with the transmission line. Telephone wires, these are nothing but the pilot wires. Okay, from one end to another end, between the two transformer we have connected these two lines with the our regular transmission line. That is we called as a pilot wires, pilot relay. Okay, see, pilot relaying scheme used to protect the transmission line section. Okay, when they fall into the category between the init zone, okay, init protection zone, so that some electrical quantities at the two ends of the transmission line are compared, and hence they require some sort of interconnecting channel over the information can be transmitted from one end to another end. To transmit information from one end to another end, we have to connect an interconnecting channel that is called as pilot. Okay, there are different types of channels we have to use. That is, first one is wire pilot, second one is carrier current pilot, and third one is microwave pilot. A wire pilot, it is a private cable. Alternatively, that is nothing but rented post office or private telephone lines. And carrier current pilot is having a low voltage with a high frequency up to 50 kilohertz to 700 kilohertz is used to transmit information from one end to another end. Okay, next pilot signal is a coupled, that is a two wire we have to use directly to the high voltage line which is to be protected. This type of pilot is also called as power line carrier. And microwave pilot is a radio channel of very high frequency, about 450 to 10,000 megahertz. A wire pilot is used economically for distances up to around 30 kilometers. Okay, a carrier current schemes are more economical for the longer distances when the number of services requiring pilot channels exceeds the technical or economical capabilities of carrier current pilot. Here the microwave pilot is employed for that one. Okay, the distance around 150 kilometer. Otherwise it is limited to the hills and buildings. Okay, to operate around 40 to 60 kilometer without repeater stations, the link may operate it. Okay, the system is applicable only where there is a clear line of sight between stations. Okay, this is what about the pilot relaying schemes. In that we have to study about the wire pilot. Okay, this is for the telephone wires, carrier current for the low voltage and high frequency, microwave for the higher frequency 450 to 10,000 megahertz. That is the radio signals and all. Okay, that is microwave pilot. See here, first we have to see wire pilot protection. In that we are going to study about circulating current schemes, balanced voltage schemes, translate protection, half wave comparison scheme. Okay. Then what about the wire pilot protection? The wire pilot protection carries the two wires used to transfer the information, that is signals, from one end to another end. That is the protected line. We have to protect it. We have to connect two extra wires to carry the information from one end to another end. It may be buried cable or a pair of overhead wires, or it may be power line conductors. It operates on the principle of differential protection. The comparison is made between the current transformer secondary currents at the two ends of the line. That is nothing but, see here, two ends of the lines, secondary transformer carries the two pilot wires. Is it clear? Extra two lines are connected with the transmission line, that is from the transformer secondary side. Okay, a single phase current is derived from the three phase. If it carries single, means a single phase current is derived from three phase currents at each end of the line. Therefore, using only one pair of pilot wires to carry the information signal. For short lines, wire pilot schemes are less expensive than the carrier current schemes because terminal equipment is simpler and also it is cheaper. Okay. For the most consideration, we have to use it is for around 15 to 30 kilometer, but distance is usually limited due to the attenuation of signal caused by distributed capacitance and series resistances. Okay, we have to see the cost of this. For short lines, wire pilot relaying is recommended. For slow speed over current relays are employed for the short lines. Okay. For long lines, carrier current schemes are cheaper and more reliable than the wire pilot schemes. There are two alternative operating principles which are used for most of the practical schemes, that is circulating currents principle and balanced voltage principle. The most wire schemes are used amplitude comparison in circulating current scheme, okay, to apply multi-ended lines and are less affected by the application, that is pilot capacitance. In that we are going to see circulating current schemes. Okay, this is about circulating current scheme. Okay, this is circulating current scheme. Here the circulating current scheme is used for the pilot loop resistance up to the 1000 ohm and for the inter-core capacitance up to 2.5 microfarads. See the polarities of the secondary voltage. Here one transformer and here current transformer. Secondary of these two transformers connected here series. That is interconnected by the pilot wires. Two pilot wires are connected in series with the secondary of these two CTs connected at the end of the transformer. Okay. See here. What happened in the normal condition, or it may be external faults. Okay, external faults means that faults not in the our protected zone of the protection. Here we are considering that fault, it is not in the protection zone. That fault is treated as the external fault here. If in the external faults and in the normal condition, what happened, the incoming current is equal to outgoing current. There is no difference, there is no fault occurs here. Therefore, whatever in the normal condition, normal current is entering and then outgoing current, both are equal. There is no difference in that current. Okay. So what happens if any fault occurs between the lines, intermediate fault occurs? What happens in that condition? Incoming current, heavy current and outgoing current is different because fault occurs between the two end of these two, there is a transmission line is there, right? Okay, if fault occurs between them, there is a difference between the entering current and outgoing current. Is it clear? Therefore, that difference between these two currents that is going through this pilot relays. Here, the pilot relays, there is a relay connected, right? Here one relay and here a second relay, and one more circuit breaker here and one more circuit breaker here, right? So that relay detect that difference between these two current and how much difference current is flowing. That current flowing through the operating coil. At that time, what happened? The polarities of the remote end of these CT get reversed, and hence current flowing through the operating coil of the relay. That difference current is detected by the relay and it sends the signal to the circuit breaker, and hence circuit breaker gets trip the circuit. Is it clear? At the normal condition or at the external condition, external faults, the current does not flow through the operating coil. Current does not flow through the operating coil. It is going through the restraining. Normal condition, there is no current difference, hence there is no current flow through the operating coil. You know that the concept in the first module you have discussed that when the operating coil produces torque and restraining also produces torque, right? When operating is greater than restraining, that time relay detects the signal and sends the signal to the circuit breaker. That is what in the faulty condition. Hence here also same thing. At the normal condition, or it may be fault that is outside of zone of protection, at that condition there is no flow of current through this operating coil. Okay, there is no difference, there is no detect by this relay, hence normal condition, there is no difference in the current. If the fault occurs between these two ends of the protected line, that there is a difference between entering current and outgoing current, because fault occurs here, outgoing current is different. That difference between current is detected by the relay, that current is flowing through the pilot wires, right? Wire is connected here, that difference current is flowing through here through the current operating coil. This is operating coil and R is restraining coil. Therefore, the relay detects this signal and sends the signal to the circuit breaker to the circuit. This is what schematic diagram of circulating current principle, and one more diagram is given in your textbook, that is this one, practical. Okay, this is your practical scheme based on circulating principle. Same principle here also apply. This is what practical we are using like this. This is about circulating current scheme in the wire pilot protection, right?